Hello everyone, welcome back to Vysh IAS YouTube channel. This is Pooja Sharma and I'm back with the next chapter. So before we begin, here are the contact details of Vysh IAS. You can contact on this number for your enrollment details and any doubts regarding your UPSC preparation. So let's begin. So this chapter deals with atmospheric circulation and the weather system. So as you can see, we're going to read about all this in detail. So as we all know that the air expands when it gets heated and also it gets compressed when it's cool. So we also know that warm air tends to rise and the cool air will tend to it'll go down. So this results in variations in the atmospheric pressure. Because of that only there is this creation of high pressure and low pressure belts and regions. So the result is that what happens is it will cause a movement of the air, which will lead the air to go from a high pressure zone to a low pressure zone. So this will set the air in motion. It will start moving. So we all know that air which is moving in horizontal motion, it is called wind, or moving air is wind. And also the atmospheric pressure, it also determines when the air will rise and sink. As I said earlier, the warm air rises and the cool air will sink. So the wind, it redistributes all the heat and moisture because of the molecules which are present, okay, and this happens across the entire planet, and it will also maintain this constant temperature which it carries from a place to another. So the vertical rising of moist air cools down to form clouds, and thereby it will bring rain or precipitation. So in this chapter mainly we are going to know about the causes of pressure differences and the forces that lead to atmospheric circulation and how it gets controlled, and then also the turbulent pattern of wind, how there are high pressures, low pressures and different movements, obstructions and all of that. And also we will learn the formation of different types of air masses around the world and the disturbed weather when the air masses will interact with each other, and also the violent tropical storms like thunderstorms, dust storms, tornadoes, all of that. So atmospheric pressure, uh, we all know that our body is subjected to a lot of air pressure. We don't feel it, but it is present around us. Also, as one moves up at a higher elevation, what happens is we start feeling breathless because the uh, pressure will start decreasing and even the temperature will start decreasing. So the weight of a column of air contained in a unit area from the mean sea level to the top of the atmosphere is known as the atmospheric pressure. So the atmospheric pressure, it is expressed in the units of millibar, MB. So at sea level, the average atmospheric pressure, it will be 1013.2 millibar. And also due to the gravity which is present in the air at the surface, it is denser. So what will happen is it will cause high pressure. So the air pressure is measured with the help of a mercury barometer or the aneroid barometer. So as you can see over here, as we go up, there will be low pressure, and as when a body is situated at a surface area, it will be high pressure. I think I made a mistake earlier, sorry. When we go to a higher place or a higher region, there will be low pressure. So the pressure decreases with height, yes, and at any elevation it varies from place to place. It won't be the same, and mainly the difference why it will not be the same is because of the air which is in motion. So wind which will move from higher pressure areas to low pressure areas, it will be different because of the direction of wind and movement of wind. So in the lower atmosphere, the pressure decreases rapidly with height, and the decrease, it amounts to about 1 millibar for each 10 meters increase in elevation. So it does not always decrease at the same rate. At different regions there will be different rate of change, And as you can see in this picture over here, it gives us the average pressure and the temperature which is at selected levels of elevation, at 1 kilometer, at 5 kilometer, at 10 kilometer, you know, how much the pressure is, and along with the temperature also. So the vertical pressure gradient force, it is much larger than the horizontal pressure gradient, but what happens is it will get balanced by a equal and opposite gravitational force. So that's why we don't experience too much strong upward winds, and it doesn't make much of a difference. So then we have the horizontal distribution of pressure. So what happens is small differences in pressure, they are highly significant in terms of wind direction and velocity. It depends mainly on the direction and the speed. So the horizontal distribution of pressure is studied by drawing these isobars at constant levels on the map, and also these isobars or lines will still connect places which have equal pressures. So in order to eliminate the effect of altitude on pressure, what will happen is it is measured at any station after being reduced to the sea level for the purpose of comparison to make the calculation more easy. So the sea level pressure distribution is shown on weather maps, as you have seen earlier. So in this picture we can see the isobars, pressure and wind systems in the northern hemisphere. So what happens is it shows us that these isobars which are present over here, they will be corresponding to the different types of pressure systems which are seen in the northern hemisphere in this picture. And the low pressure system, it is enclosed by one or more isobars with the lowest pressure in the center, and the same happens for the high pressure. High pressure system, it will be enclosed by one or more isobars which will have a highest pressure in the center. Enclosed means it will be surrounded by. So this is the world distribution of sea level pressure, which is of the month of January and July. So near the equator, what will happen is the sea level pressure, it will become low, and the area is known as equatorial low. And along the 30° north and the 30° south latitude, you can find that high pressure areas which are known as the subtropical high. So further polewards, towards the pole, what happens is at 60° north and 60° south latitude, the low pressure belts, they'll be termed as the subpolar lows. So near the poles, what happens is pressure will be very high, and it is also known as the polar high. So these pressure belts, they'll be not permanent in nature, it will keep varying from time to time. So they'll oscillate with the apparent movement of the sun. So in the northern hemisphere in winter, what will happen? They'll move southwards, and in summer they'll move northwards. It will be opposite. So then we have forces which are affecting the speed and direction of wind. So the air is basically set in motion because of the various differences which takes place in the atmospheric pressure, and the air in motion is called wind, as we know, and the wind, it blows from high pressure to low pressure, the same point. So the wind at the surface, it will experience some form of friction or obstruction. So in addition, what happens is the rotation of earth, that will also affect the wind movement, because sometimes it will be totally coming in opposite directions. So the force which is exerted by the rotation of the earth, it is known as Coriolis Force. And the horizontal winds near the surface of the earth, they'll respond to the combined effect of three main forces. One is the pressure gradient force, the Coriolis force, and the frictional force. And along with this, what will happen? There will be the presence of gravitational force also, which will act downwards. So as you can see, this is the pressure gradient force, and the differences in atmospheric pressure produces a force. Okay. So the rate of change of pressure with respect to distance is pressure gradient. So here you need to keep in mind the word distance. So the pressure gradient is strong where the isobars are close to each other, and it will be weak where the isobars will be apart or far away from each other. Next we have the frictional force. So as we all know, we've read it earlier also during our school days. So frictional force, it affects the speed of wind because it will form this certain type of obstruction type. Okay, so it is greatest at the surface, and its influence generally extends up to an elevation of 1 to 3 kilometers. So over the sea surface, the friction will be minimal, because even the movement of water will, cooperate with the wind movement. So there will not be too much of obstruction until and unless the waves are in the opposite direction, which will again result in storms and all of that. So Coriolis force. So what happens is the rotation of the earth about its axis will affect the direction of the wind. So this force is called the Coriolis force. So you can take an example of the merry-go-round which we have. So if it is turning in one rotation and you trying to make any movement in the opposite direction, obviously you will feel some type of obstruction, or it will be difficult. That movement will be difficult. So what happens is, this Coriolis force was I think named after the French scholar who described it in 1844, and it deflects the wind to the right direction in the northern hemisphere and to the left in the southern hemisphere. So you need to remember that in the north, remember right hand, and in the southern hemisphere, remember your left hand. So that is how you can remember it, the deflection path. And the deflection is more when the wind velocity will be high, because the speed will be too much. So because of that, the deflection also, it will become double. So the Coriolis force, it is directly proportional to the angle of latitude. So as you can see over here, the deflected path. So it is maximum at the poles and it is absent at the equator, because as you can see, equator, it is I would tell that it is proportionate, and what happens is towards the pole it gets little narrower. So what happens is over there it will become little high because of the narrow nature. So the Coriolis force, it acts perpendicular to the pressure gradient. Perpendicular is that the ulta T, inverted T. So that is perpendicular to the pressure gradient force, and the pressure gradient force is perpendicular to the isobar which is present at different regions. So the higher the pressure gradient force, the more is the velocity or speed of the wind, and this will cause a larger deflection in the direction of wind. So you have to remember three things: high pressure gradient force, then the velocity will also be high, and then high deflection. So all three situations will be high, high, high. Pressure gradient force, our velocity or speed, and the deflection. So this is easy to remember because all three conditions are high. So as a result of these two forces which are operating perpendicular to each other, in the low pressure areas, the wind will blow around it. So at the equator, what happens is the Coriolis force, it will be 0, and the wind will start blowing perpendicular to the isobars. So these low pressure belts, they'll get filled instead of getting intensified. They'll slow down. So that is a reason why mainly the tropical cyclones, they are not formed near the equator, because there it will not be so powerful. So next up we have pressure and wind. So what happens is the velocity and the direction of the wind, they are the net result of the wind generating forces. So these two main factors play a very important role. So the wind in the upper atmosphere, like 2 to 3 kilometer above the surface, they are free from frictional effect of the surface, obviously, because most of the time it will be empty, and they are controlled mainly by the pressure gradient and the Coriolis force, because there will be no certain obstruction in the path. So what happens is, when isobars, they are straight and when there is no friction present, that time the pressure gradient force, it will get balanced by the Coriolis force, and then what will happen is it will result in blowing parallelly towards an isobar. Along with the isobar, it will blow in a straight line parallel to the isobar. So this type of wind is known as the geostrophic wind. So as you can see over here, this V, it is the geostrophic wind which is going parallel along with the isobar. These two lines are the isobars. And we have our horizontal pressure gradient and the Coriolis effect, which is taking place. So as you can see, in the northern hemisphere it's moving towards the right, and in the southern hemisphere it's moving towards the left. So the wind circulation around a low is called a cyclonic circulation. So around a high, it is called as the anticyclonic circulation. So you have to remember this. The wind circulation around a low is called a cyclonic, which is circular, direction, and around a high it will go in anti-clock direction, because of the pressure, it will tend to change the direction, so it will start moving in anti-clockwise. So that's why it's anticyclonic. So what happens is, now as you can see in this table over here, this is the direction of the wind, which changes according to the location in different hemispheres. So cyclone, what happens is, at a low in the northern hemisphere it will move anti-clockwise, and in southern hemisphere it will move clockwise. Same way, an anticyclone in a high pressure condition, what will happen, it will move in clockwise and anti-clockwise direction in the northern and southern hemisphere. So the wind circulation at the earth's surface around a low and high, on many occasions it will closely be related to wind circulation at a higher level. So generally what happens is, over a low pressure area, the wind will converge and rise. Converge is meeting at a point, okay? And over a high pressure area, the wind will, or the air will, subside from above and diverge at the surface. Diverge is moving in different directions. So apart from convergence, what happens is, some eddies, convection currents, orographic uplift, and the uplift along the fronts, they'll cause this rising of air, and this is very essential for the formation of clouds and precipitation. So next we have the general circulation of the atmosphere. So this is a pattern of all the planetary winds, which are largely dependent on the following factors. One is the latitude variation, different latitudes, different latitudes, and also the atmospheric heating which takes place. Then the emergence of pressure belts. Then we have the migration of belts because of the apparent path of the sun's, the way they follow the path of the sun. And then the distribution of continents and ocean, and then the rotation of the earth. So what happens is, the pattern of movement of these planetary winds, all these winds that you can see, different types of winds over here, they are called as the general circulation of the atmosphere. So what happens is, the general circulation of the atmosphere, it also sets in motion the ocean water circulation. So this is important because it influences the earth's climate. So what happens is, the air at the intertropical convergence zone, it will start rising because of the convection which is caused by the high insolation, and a low pressure is created. High isolation is the incoming solar radiation, and because of that a low pressure is created. So then what happens is, the wind from the tropics, they'll start converging at this low pressure zone, meeting at one place. They'll come to one place, to this low pressure zone, because wind moves from high pressure to low pressure. That is common. So the converged air, it will start rising along with the convective cell. So it reaches the top of the troposphere up to an altitude of 14 kilometers, and then it will start moving towards the pole. So this causes the accumulation of air at about 30 degree north and south latitude. So the part of the accumulated air, it will start sinking to the ground, and it will cause this, form this subtropical high on the upper regions. So another reason for sinking is the cooling of air by the time it reaches this 30 degree north and south latitudes. Okay, because the air won't be constant, the temperature won't be constant. It will keep changing its temperature according to the air which is moving around in that particular direction. Once these winds, they start, they crash or meet together, there will be this exchange of temperature. So down below near the land surface, the air will start flowing towards the equator as the easterlies, in the form of easterlies. So the easterlies, they will, what they'll do is, the easterlies from the either sides, on both the sides of the equator, they'll converge in the intertropical convergence zone. So they'll come and meet up at this place, and then such circulations from the surface upwards, and also vice versa, they are called as cells. So such a cell in the tropic region is called as the Hadley cell, and in the subtropical it is known as the Ferrel cell, and in the polar region it will be polar cell. So what happens is, in the middle latitudes, the circulation of that sinking cold air, it will come from the poles, mainly from poles, the cold air, and then the rising warm air that blows from the subtropical high. So these will meet up. So at the surface, these winds are called as westerlies, and this cell is known as the Ferrel cell. So at polar latitudes, what will happen is, the cold dense air will start subsiding near the poles, and they will start blowing towards the middle latitudes as the polar easterlies. So this cell is known as the polar cell. As you can see over here, polar cell is over here, Ferrel cell is over here, and then we have Hadley cell over here. So these three cells, they will set the pattern of this general circulation of the atmosphere, and the transfer of heat energy from the lower latitudes to higher latitude maintain the general circulation. As I said earlier, how when wind meets at different regions, there will be exchange of heat, or it will take that temperature. So the general circulation of the atmosphere, it also affects the ocean. This is very important, the El Nino. So the large scale winds of the atmosphere, they'll initiate large and slow moving currents of the ocean. So the ocean in turn provides input of energy and water vapor into the air. So that is how the whole process of precipitation, evaporation takes place. And these interactions it will take place rather slowly over a large part of the ocean, because it takes a lot of time for the water droplets to evaporate and all of that. So the general atmospheric circulation and its effect on ocean warming, and also the cooling of the Pacific Ocean, these are the most important in terms of the general atmospheric circulation, because it determines weather in the longer term. So the warm water of the central Pacific Ocean, it will slowly start drifting towards the South American coast, and it will replace the cool Peruvian current when the exchange of heat will happen. So from warm, it will again turn into cold current. So such appearance of warm water off the coast of Peru is known as the El Nino. So the El Nino event is closely associated with the pressure changes in Central Pacific and Australia. So these two regions are main. So this change in pressure condition over Pacific, it is known as the Southern Oscillation, as you can see over here. So the combined phenomenon of Southern Oscillation and El Nino is called as the ENSO. So in the years when the ENSO is strong, large scale variations will take place in weather, and it will occur almost all around the world. It will affect or impact the whole world. So the arid west coast of South America, it receives heavy rainfall, and then even droughts occur in Australia. Sometimes in India and China, it will start flooding. So it is mainly because of this El Nino phenomenon. So this phenomenon is closely monitored, and it is used for long range forecasting in major parts of the world, as I said earlier. So then we have seasonal winds. So the pattern of wind circulation, it will keep changing in different seasons due to the shifting of region of maximum heat, the pressure and the wind belts. So the most pronounced effect of such a shift, it can be seen in the monsoons, especially over Southeast Asia. We have read about these two types of monsoons, which is the northeast and the southwest monsoon. So the other local deviations from the general circulation system, they are as follows, which we'll be reading in the next slide. So the first one is the local winds. So differences in the heating and cooling of the earth, it will start, see, everything starts from the root only, right? So the roots will be the local winds, which will form around the region. So these differences in heating and cooling of the earth's surfaces and the cycles which will develop daily or annually can create several common local or regional winds. Everything will start from here. Then we have land and sea breezes. So what happens is the land and the sea, they absorb and transfer heat differently, okay, because of the difference in molecules and all of that. So during the day, the land will heat up very fast and it will become warmer than the sea, because the sea will take a lot of less time to heat up. So therefore, over the land, the air will start rising, okay, and this will give rise to a low pressure area. So whereas what will happen in the sea, it will be relatively cooler than the land. So there the pressure will be relatively high. Then what will happen? A pressure gradient from sea to land is created, and the wind will start blowing from the sea to land, because it moves from high to low pressure area. Okay, so the wind will blow from sea to land as the sea breeze. So in the night, what will happen? The reversal will take place, because in the night the earth will cool down. So what will happen is the land will lose its heat faster and is cooler than the sea. The sea will become little warm in the night. So the pressure gradient is from land to sea, and hence it is called as a land breeze. Then we have the valley and the mountain breezes. So in mountain regions, what happens is during the daytime, the slopes will get heated up very fast and the air will move up slope, and it will start filling the resulting gap. So the air from the valley, it will blow upwards to the valley, and this wind is known as the valley breeze. So during the night, what will happen? The opposite. The slopes will get cooled and the dense air will descend into the valleys as the mountain wind. So the cool air of the high plateaus and the ice fields, they'll start draining into the valley, and they are known as the katabatic wind. So another type of warm wind will occur on the leeward side of the mountain ranges, the rain shadow area. So the moisture in these winds, while crossing the mountain ranges, it will start to condense and precipitate. Obviously rainfall will occur, as we read in the earlier chapters. So when it descends down, what will happen towards the side, the slope of the dry air, it will get warmed, and this is by the process of adiabatic process. So this dry air, it will sometimes melt the snow in a very short time. Next we have the air masses. So what will happen when the air remains over a homogeneous area for a sufficiently longer time, it acquires the characteristics of that area. It will adapt to those conditions. So the homogeneous regions, they can be vast ocean surface or even vast plains. So the air with distinctive characteristics in terms of temperature and humidity is called an air mass. So it is defined as a large body of air having little horizontal variation in temperature and moisture. Moisture is nothing but the water content. So the homogeneous surfaces over which the air masses will form and stay there for a constant period of time, they are called as the source regions. So the air masses, they are classified into 5 major source regions. So these are the warm tropical and subtropical oceans. Then we have the subtropical hot deserts, the relatively cold high latitude oceans. Then we have the very cold snow covered continents in higher latitudes, and then the permanently ice covered continents in the Arctic and Antarctic region. So as you can see over here, these are the different types of air masses which are present in the world. So accordingly, they are these 5 types of air masses which are recognized. So the first one is the maritime tropical, MT. So if you can see over here, MT in green over here, okay. And then we have the continental tropical, CT. CT is over here in between MT and it's in between MT. Then we have the maritime polar, MP, which is over here in between, it's in purple, it is in between CP, and CP is our continental polar. So you can see it is named according to the place also where it is a polar region. So, continental polar, then maritime polar, and then the last one is the continental Arctic, which is the CA. So, our CA is right here on top and right here, ekdam in the bottom. So, tropical air masses, they are warm, and polar air masses, obviously they'll be cold because of the region. So, then we have fronts. So, when two different air masses meet, the boundary zone between them is called a front. So, the process of formation of these fronts is known as the frontogenesis. So, there are four types of fronts. One is the cold, warm, stationary and occluded. So, when the front, it will remain stationary or constant. Obviously, it is known as the stationary front. Then, when the cold air will move towards the warm air mass, its contact zone is called the cold front. And obviously, the warm air mass will move towards the cold air mass. So, that will be known as the warm front. So, if an air mass is fully lifted above the land surface, it is known as the occluded front. So, the fronts occur in the middle latitude regions and they are characterized by steep gradients. Steep gradients are these slope type, okay, in temperature and pressure. So, they bring abrupt changes in temperature and they'll cause the air to rise and form different clouds and cause rainfall, precipitation. So, then we have the extratropical cyclones. So, the systems developing in the mid and the higher latitudes beyond the tropic region, they are called as the middle latitude or the extratropical cyclones above the tropics. So, the passage of the front, it will cause abrupt changes as we read earlier in weather conditions over the area in the middle and these higher latitudes. So, these extratropical cyclones, they'll form along the polar front, the boundary of the warm and cold front. So, initially this front will be stationary, it will be constant. Then what will happen in the northern hemisphere, the warm air will blow from the south and the cold air will blow from the north to the front and they'll form this boundary. So, when the pressure will start dropping along the front, the warm air, it will start moving towards the north and the cold air will move southwards. So, this will set in a anti-clockwise motion, anti-clockwise cyclonic circulation, and it will lead to a well-developed extratropical cyclone which will form a warm front and a cold front, the boundary where it will get formed. So what will happen, there will be these pockets of warm air or a warm sector which will be wedged between the forward and the rear cold air or the cold sector. So as you can see in the picture, you can see warm air over here and you can see cold air on both the sides, and even over here cold air and warm air is in between. So this warm air will start gliding over the cold air and a sequence of clouds will start appearing over the sky in front of the warm front, and this will cause rainfall. So the cold front, it will start approaching the warm air from behind and it will push the warm air up because warm air will be lighter. So as a result of this, cumulus clouds will be formed and they'll develop along the cold front. So the cold front will start moving faster than the warm front and it will ultimately, completely go in the front, overtake the warm front. So this warm air, it will completely be lifted up and the front, it will be occluded. Occluded is when it will move completely away from the surface, and then the cyclone will start dissipating. So the processes of wind circulation both at the surface and aloft, they will be closely interlinked. So this extratropical cyclone, it will differ from the normal tropical cyclone in a lot of ways. And this extratropical cyclone, they'll have a very clear frontal system, and this will not be present in the tropical cyclones. So they'll cover a very larger area and they can originate over both land and sea, but our tropical cyclones, they'll occur only in the sea. So as I said now, by the time they reach the land, the tropical cyclones, they will dissipate. So the extratropical cyclone, it will affect a very larger area as compared to the tropical cyclone, and also the wind velocity in a tropical cyclone will be much higher and it will be very destructive. So the extratropical cyclones, they'll move from west to east, but the tropical cyclones, they'll move from east to west. So next we have the tropical cyclones. So tropical cyclones, they'll be very violent in nature. They are violent storms. So they'll originate over oceans in the tropical areas, and they'll start moving towards the coastal areas, bringing about large scale destruction, which is caused by the violent winds and the very heavy rainfall which comes along with it, and also the storm surges which we read about earlier. So this is one of the most devastating natural calamities, and they are also known as cyclones in the Indian Ocean, hurricanes in Atlantic, typhoons in Western Pacific, and also in South China Sea, and they are called as the Willies in the Western Australia. So the tropical cyclones, they'll mainly originate and intensify over these warm tropical ocean regions, and the conditions which are favorable for the formation and the intensification of a tropical storm is large sea surface with temperature which will be more than 27 degrees Celsius, then the presence of Coriolis Force, also small variations in the vertical wind speed upward, and a pre-existing weak low pressure area, and also a low level cyclonic circulation, little bit, which will be the starting of a cyclone, this cyclonic circulation. Then we have the upper divergence above the sea level. So the energy that intensifies the storms, it mainly comes from the condensation process in the towering cumulonimbus clouds. So the surrounding the center of the storm. So they'll be all around the storm, these clouds. So with continuous supply of moisture from the sea, the storm is further strengthened and it will start raining, because what will happen when this cyclone is formed, there will be continuous supply of moisture or water droplets will start rising up, okay, and then the storm will be strengthened because of the heavy rainfall. So on reaching the land, the moisture supply is cut off and the storm dissipates. So the place where a tropical cyclone crosses the coast, it is called as the landfall of the cyclone. So the cyclones which cross 20 degree N latitude, generally they'll take a recurve and they'll become very more destructive. So a mature tropical cyclone, it is characterized mainly by strong spirally circulating wind around the center, which is called as the eye, as you can see in the picture over here. So the diameter of the circulating system, it can vary between 150 to 250 kilometer, and the eye is the region of calm. It will be very calm and it will have this subsiding air. Around it only the main, the powerful cyclone will take place. So around the eye is the eyeball, where there will be the strong spiraling ascent of air, which is a greater height reaching the tropopause. So the wind reaches to a maximum velocity in this region, which will reach up to 250 km per hour, and the torrential rain occurs in this region. So from the eye wall, rain bands will start forming and they will start radiating towards the outer region. So this will mainly be the trains of cumulus and the cumulonimbus clouds, which will drift in the outer region. As you can see over here, NB and CU, these are the clouds, the rain bands which are forming. So the diameter of the storm over the Bay of Bengal and Arabian Sea in the Indian Ocean, it will be between 600 to 1200 kilometers. So the system will move slowly about 300 to 500 kilometers per day. And these cyclones, they'll start creating storm surges and they'll flood the plains, the coastal lowlands, and the storm will peter out on the land. Peter out means it will slow down, gradually when it reaches the land. So then we have the thunderstorms and the tornadoes. So over other severe local storms are thunderstorms and the tornadoes. So they are of short duration and they'll occur over a small area, but they'll be very violent in nature and cause a lot of destruction. So thunderstorms are caused by intense convection on moist hot days, and a thunderstorm is a well-grown cumulonimbus cloud producing thunder and lightning. So as you can see in the picture, and when the clouds will extend to heights where there will be sub-zero temperature, hails will be formed. Snowfall. Hails are formed and they come down as hailstorm. So if there is insufficient moisture, a thunderstorm can generate into a dust storm if there is very less water content in the air. So a thunderstorm is mainly characterized by intense updraft of rising warm air which will move upwards towards the sky. So this will cause the clouds to grow bigger in size, and it will rise to greater height because this warm air will push them upwards. So this causes precipitation or rainfall. So later what will happen, the downdraft, it will bring down to the earth cool air and rain. So from severe thunderstorms, sometimes spiraling wind will descend like a trunk of an elephant, like that U shape, with a great force, and it will be of a very low pressure at the center. So this will cause massive destruction in its way, whatever comes in its way. So next we have the tornadoes. So such a phenomenon is called a tornado. So tornadoes, they generally occur in the middle latitudes, and the tornado over the sea is called a water spout. So these violent storms, they are the manifestations of atmosphere adjustments to varying energy distribution that takes place. So the potential and the heat energies, they are converted into kinetic energy in these storms, and then the restless atmosphere again returns to its stable state. We all know that Earth and the ecosystem, it can maintain its balance after a certain period of time, gradually. So that's all for today. I hope you found this chapter interesting, and I hope you found this video useful. Please make sure to like, share and subscribe to this channel. Also leave a one-liner comment about any feedback for the video. So I'll be back with the next chapter. Until then, all the best and thank you.